Good morning, everyone. And this time it is morning. Just adjust my camera. Oops. I'm not actually on the first slide. I'm on where I was last looking at the slides. Let me get that going. All right. A little bit of chat there earlier. Oh, Liang got up at 9 a.m. I apologize. I did when did I send an email out? It was only on Sunday, so it was only 2 days ago. So I'm sorry if me slightly changing the schedule has made it harder to organize. But I think for a lot of people, just another hour in bed is nice because knowing that there's no other, well, I don't know that there's no other scheduled content, but unlikely to be much other scheduled content this week. I thought I'd give us all a little bit of a rest and and back it off 1 hour. And I don't know about you, but I definitely didn't get up before 9 today because when you're working from home, you don't really have to get up that early. Just make sure everyone can hear me. Just ping me in chat if you can hear me because I'm pretty sure that everyone should be able to, but every now and then I stuff up. Volume's okay as well. Okay, that's good. My little bars aren't going as high as they normally do, but I think it's probably going to be okay. All right. So today, as I've been talking about before, this week is flexibility week, which means that if you want to, you can take the whole week off and still have everything you need to do Comp 1511. So the only thing I'm doing today is clarifying the use of things that I've already told you about, specifically the newest stuff. So I'm going to do some stuff with Structs. I mean, like in the normal lectures that start again next week, we're also going to be doing stuff with Structs, so it's not going to be necessary, but it's like a fun little example that is going to go a little bit more in depth than our normal coding things, because since I don't have to present a topic or anything or present the theory of anything and and explain why and how something works, what I can do now is just go, all right, we're just going to launch straight into code, and we're gonna write some code, and we can spend the majority of the 2 hours just writing a piece of code. Having said that, actually don't know if this is going to take 2 hours. But obviously this kind of stream is going to be more open to people asking questions and stuff like that if you want to. I don't think anything in particular that I'm doing today is going to help much for the assignment, so it's not super necessary or anything like that. The stuff that I'm doing might actually be more of help in the second assignment than the first assignment, because really, when we think about it, we were done with all of the techniques we needed for the first assignment by the end of week 4, I'd say. So now that we're in week 6, even the week 5 stuff, strings and structs that we've talked about weren't really super relevant for assignment 1. I had a couple of people ask if they could use some of that stuff. I mean, strings, I don't think you definitely really need them. Or you definitely don't need them, but I'm not sure how I would put it together to use them and have it actually be something that makes the assignment either easier or more effective. Someone was saying something about using characters instead of numbers for some parts of it. Someone else asked about using structs in the assignment. Was like, yeah, if you really want to, but none of it's necessary. So today, what I'm going to do is create a program that's called Bender Fight, which is about 4 element benders having a fight in a forest against an enemy. So the thing I'm referencing here, and I first wrote this example mid to late last year when when Avatar: The Last Airbender came back on Netflix, and I was watching that, and I was really, really enjoying it. I'm trying to keep this spoiler free, at least a little bit spoiler free. Like, if anything, it won't spoil anything past the first sort of 3 or 4 episodes of the first season, if that. Um, so, uh, yeah, I was watching and it was kind of fun. And I thought, oh, this would be great. I'll use this as an example. And then I realized that it was absolutely perfect because the original Avatar came out in, I think it was 2006, 2007, which was just around the time that everyone I was teaching at the time was a kid and was like definitely watching stuff like this, and so everyone loved it. And I've actually just started watching it again because my partner's never seen it. Um, and she didn't get involved last time I was watching it, so I was like, oh, that's all right, we're gonna sit down and I'm gonna show you the whole thing. And Tom, you're fired, because no, I still haven't seen the M Night Shyamalan. I'm not sure exactly how to pronounce the last name. I haven't seen the movie, but everything I've heard about the movie is that it's a massive disappointment the if you like the TV series. So I just think that it's probably better if I just don't go anywhere near it. Okay, so let's talk code. Let's talk the structure of what we're doing. So, team of 4 benders against one very powerful enemy. So we're setting up the idea of, like, we've got certain data structures. One of those data structures is going to have 4 benders in it, and the enemy is going to be another. So we're going to create a struct that represents a bender. So if you don't know the Avatar: The Last Airbender, the TV show, a bender is just a person, but a person who has certain magical powers, the ability to bend an element to their will. You know, so there's water, earth, air, and fire as the 4 elements in the TV show, and then there's a bit of conflict between them because the Fire Nation has attacked the other nations. No spoilers there because that's in the opening before even there's anything else happening in the show. So we're going to have a firebender against a bunch of others. And the firebender is going to be the one that fights all of the others. And what we're going to do is make some functions that put these fighters against each other, the benders against each other, and have them attack each other in a way. And it's not really a game, it's not interactive, but it's just going to keep looping attacks until either all 4 of the benders are knocked out, or the firebender themselves, the opponent, is knocked out. And so we're going to set up these structures so that we can keep track of what each character is doing, keep track of the attacks and stuff that happen, go through a sequence of attacks, and stop when either team is forced to stop. Oh, and Tom's saying Bender is a robot from the year 3000. Everyone should press F for respect for Tom, who is never going to be working on 1511 again. It's sad, you know, but these things happen. Okay, so the structure is going to be the struct itself is going to look like this. So what we're going to do is use a really similar one to the one that we were using in our last lecture, where we were tracking performers. But this time it's going to be tracking these benders. And so each of the benders has a name, and then they have the element that they use. So each one of them sort of tied to a particular element. And then each one's going to have power, which we're going to use as this kind of the amount of damage or whatever that they can do, and then they're going to have a certain amount of health, which is how much they can take before they get knocked out. So it's very kind of similar to a really simplified version of how we would do characters in a computer game or a role-playing game like Dungeons and Dragons and stuff like that. You know, we've got some statistics that govern what the character does. Let me just hop into VLab. Go to my comp1511 directory. I'll make a new directory. I'll just call it live stream, I think. I don't know how often I'll specifically be doing code in live stream. So I'll just grab create a new directory like this, and I'll be in here. I'm gonna call this Bender Fight. People are putting F in chat. Leon's asking if your VLab folders stay even when you're finished 1511. Yes, they will, but eventually, excuse me, eventually I think they won't. So the stuff stays, but whether you have access to VLab, I think, is potentially based on whether you're a current CSE student or not. Obviously, I don't know that much about whether when access is created or revoked or anything like that, because as staff, I've kind of got access all the time. Tom might know. Yeah, there you go. You have to be enrolled in a computing course. So if you're enrolled in a course that starts with comp, that means you're part of CSE and you'll have this account. So if you're going on to other courses in CSE, you'll be using the same account. Which means you'll have access to your 1511 stuff. Alright, so let's start with our comments explaining what this is. So we're going to, I'm just putting a clue in here about all this stuff. We're going to be using structs, we're also going to be using strings and pointers. So we're gonna tie in a lot of what we've been learning recently about new concepts. So hopefully this will, if anyone's having trouble so far with everything we've learned so far about strings and pointers, maybe this will help. This is the first demo that I've done on structs, so maybe if people don't fully understand the concept, because I only spent about sort of 20 minutes, half an hour on it last lecture, this hopefully will cement that a little bit more. Where are we? July 2020. Okay. So the things that I'm pretty sure I'm going to need, I'm going to need my standard input output because I do want some stuff to come out to display to my terminal, because without that I'm not going to be able to see what's going on with my program. I'm definitely going to want some hash defines in here, but until I decide exactly what they are, I will leave them out for now. I'm going to need my struct also, but before I do that, I don't know, muscle memory just typed a different word. I'm just going to put my main function in there so that this definitely compiles. Okay, so in order to make a struct, I need to declare the struct before any of my program code, so that anything that might use my struct is going to know what it is. Structs are always created with this keyword struct, so from now on, anything that I do with the benders is going to want to know that it is a struct. So I'm creating a new variable type, and the variable type is now a two-word variable type instead of a single-word variable type like int or char or something like that. This two-word variable type is still just a variable, but it's my custom variable. So I use the word struct to say this is going to be a struct type of variable, which means it's going to be made up of multiple other variables, and the unique part of this this new type I'm making is the word bender. So this is the standard layout for a struct, and then anything I put inside the curly brackets here is going to be what variable types and names make up the fields, they call them, the pieces that are inside the struct. So let's look at what we're thinking we're going to need there. We're going to need a name and an element, and you can see here that I've definitely got a constant that I was using. Ooh, hang on a second there. Oh, that's weird. For some reason, the font here. Let's see if it works. I mean, there is a line there. I don't know why, but the font there is not working the same. But that's definitely an underscore. If I'm going to have a constant, I'm going to have it as a single set of letters with an underscore. So let's make that. So what we're saying here is that we're going to have potential size of strings for the character's name and also what was the character's name and their element. So these aren't going to be very long because the names and the elements, like I know the elements air, fire, earth, water, are never going to be more than about 5 letters. But maybe we want our max length to be a bit longer than that, just in case. So I'm going to say just in case someone ends up with a whole bunch of titles and has extra characters for them, I'm going to make the max length 100 just in case. So, character arrays here, their name, max length. So this is saying that the longest name that we can have is 100 characters, and I think we'll be fine with that. I mean, as you see, once we start building this up, we're definitely not going to use names that are 100 characters, but who knows if we were to continue using this later on, if we'd want to use this size. So I'm just playing it safe for now, making it a little bit bigger than it needs to be. I think Tom's just explaining to Leon about the whether you keep access to your account in CSE. And Michael's saying we can have Ang but with like 98 A's. Yes, we could if we really wanted to. Maybe that's like what they call him when they're like calling out for help. Okay, so each person has an element. There could be other ways to do this for the moment, especially because I just want to work a little bit with strings. I'm going to make the element a string, even though there's only like a fixed number of them. And if we wanted to, we could just be like, all right, the integers 0 through to 3 are the different elements, and we could hash define each of the elements as that up here. I'm going to keep them as a string because I think it'd just be interesting to use them for the moment. So there's not really a kind of program design decision for why I'm using this for a set of only 4 things. But I'm just going to do it so that we've got another string in here that we're using. Okay, so we had 2 integers. One was power that we were using to represent someone's capabilities. And then we have health to represent how tough they are before they get knocked out when they're in a fight. So the cool thing about this struct now is that we can use this. I'm going to put some white space at the bottom so we can put this in the middle. We can use this now to represent anyone in our little simulation. So whether it's one of the main characters or whether it's the enemy, they're actually going to be using the same struct. So the information here is generic enough that we can use it to represent all the possible characters that we're going to have in this particular program. So if we have the struct, we can create the variables, and now we'll go through the kind of characters themselves and make them. So what we're going to do is we're going to have an array of struct benders called companions. So that's just the traveling companions here. And so this is me saying what the variable can be. So this is me saying there is a thing called struct bender. It is not a variable, but it is a type. So in the same way that if I say int is not a variable. So int is a concept, and an individual variable of type int can be created. Many individual variables of type int can be created, but the concept of the int is like this struct bender here, where it says, okay, I store a certain kind of thing And under the hood here is us saying this also takes up a certain amount of memory. But this concept itself doesn't necessarily take up that memory, it just describes what it is. So I can't use struct bender as a variable, but I can create variables that are of the type struct bender. So there's this subtle difference between saying what the concept of a variable is and then actually using one. So to actually use one, so I could do this. This is now a type. This is a variable name. So this is my way of creating a single variable of type struct bender. So you get this idea now where these two words here, struct bender, are now interchangeable for any other variable type. So when we do this, like here, int ang, what this does is it goes into memory and it says, all right, I'm going to claim a piece of memory that's the right size for me to store this type, which for an integer is 32 bits. For the struct bender is significantly more bits than 32 because we've got 200 characters and 2 ints. So that should be roughly, I don't know if it's going to be exact, 1600 bits for these two because it's 8 bits times 100. Each character is 8 bits and there's 100 of them. Is it 100 or 101? No, I think there's 100. I was just trying to, oh no, because these are just arrays. I was trying to remember if that had anything special with the null terminator, but that's different. So there would be 800 bits here, 800 bits here, 32 bits here, and 32 bits here. So I think it would be 664 bits. I can't necessarily guarantee that because there's other subtleties going on, but I know it's going to be roughly around that size, which means that when I create one of these, it's going to say, all right, I'm taking my 1600-ish bits. That's a piece of memory that I'm using for that, and now this is a variable, and then ang would be a variable that I could reuse for things. But the difference here is that this is the creation of the idea of the variable, and this is the creation of one individual instance of that variable, in the same way that an integer has the idea of what it is, and you can create multiple individual integers, but you can't work with them until you've created at least one inside your program itself. So what we really kind of want to get to after we think about it for a bit is that a struct is just a variable, but it's one that we create. Dean's explaining that yes, you still would need a null terminator, so we have 97 A's on the special long ang. And Michael's asking whether a struct is like a pointer to a really big array. It's not necessarily a pointer to a really big array, but in the same way that a variable name gives you access to memory, the struct name is exactly the same concept because it is a variable. It'll give you access to memory, but the memory won't necessarily be a big array. It'll be exactly this much memory, separated into little pieces that you can use for each part of it. In the same way that an array is a piece of memory that has separate little pieces in it that you can access. When you're saying there that Michael's asking if this is a really big array, it's not necessarily a big array unless you put a lot of stuff in it. So I could have, for example, this is one that I will sometimes use in other situations. If I'm doing a maths plotting program, sometimes I find it easier to keep my coordinates in structs like this. And so this is not very big. This struct is just a set of integers, but they go together as a pair, so it's nice to use them as a coordinate. But obviously, we're not going to use that for this program, but I just want to show you that like sometimes a struct is not very big. But sometimes like this one, it's huge. So it depends on what you define. So you can get structs and you can build them up into quite significant levels of complexity, or you can just have these simple things that help you organize things better. Dean's also pointing out that you can put pointers inside a struct, you can put arrays inside a struct. Basically, any type of variable can go inside a struct, including we could have an example of a struct going inside a struct. I could even do something really full on like this. So I could say every bender. Actually, I don't know. Other doesn't really make sense. How about this one? Every bender has a best friend. And so what we have is in every bender, we could actually have a pointer to another bender that says, "Who is my best friend?" in amongst the other benders. And so you could have all of these benders with pointers to other benders. So that's possible. I'm not going to really go into that because we're actually going to look at putting pointers in structs, but not right now. I want to keep this a little bit simpler so we can understand what's going on. Okay, so we're going to make an array of benders here, which is going to be the number of companions. And we see here that we've also got another hash define that's going to be our team size. Oops. And the team size depends on exactly what you're going to do with the story at any particular time. So they have different numbers of them available to help depending on which episode they are, which season and whatever. But for the moment, I'm going to go with a team size of 4. This is a mild spoiler. I apologize, but I don't think it's going to spoil that much. But I'm going to show you 4 characters that end up together at some point in the show. Hopefully you don't mind too much. Yeah. Oh, best friend equals null. Okay, so if the team size is 4, I can, with my array here, say, okay, the array companions is of size 4. So this is the name of the variable, the array companions. This tells us how big it is. This is the type. I just wanted to point this out because things are getting a little bit more complex now, where when our type is 2 words, stuff looks bigger and harder to understand. But really, we can just think of this 2 words here, struct bender, as a single concept for the variable type that's being stored in this array. So if we're going to set up everything that's happening in these structs, we need to populate them, because when we initialize this, it's just a bunch of memory that doesn't necessarily have any values in it that are usable to us. So we need to make sure that each bender has a name, an element, a power, and a health, so that they've got values that make sense. So we're going to use some of our string functions here, which means we're going to use some of these handy functions that C provides for us in the string library, string.h. The main one of these is going to be string copy, and the reason I'm doing this is because here, when I'm wanting to set the first companion's name and the first companion's element here, which is ang, I can't do the following. So companions 0 is the first companion, and I want to set their name to ang. This bit of code here doesn't work in C. So I can't just say, take me to the first of the companions, and then go inside that struct to this name array here, and then copy this array over this. So it's the same way as we've been working with integer arrays. I can't give you a series of digits and say, all right, just copy this over. But what I need to do is copy them over one character at a time, because I can access individual elements of the array, but I can't access the whole array in one go. So instead of this, what I need to do is use one of the functions from my string.h, which is the wonderfully named strcpy, which is short for string copy. And if we want to have a look at this, I can do... So the text went all weird there. Let me just clear that so we can see it. Manual string copy. The important thing that I really want to know is with this definition of string copy, what do I need to give it? So it's saying give me a destination first and a source second. So I know that the first variable that I'm going to put in there is where I want the string to end up, and the second variable is the source that I want the string from. Don't worry too much about things like const char here or anything like that. What we're looking at is a pointer to a character and another pointer to a character, which is similar to me saying an array of characters, an array and another array of characters. So what I can do there is I can say copy into this array of characters, because I know that's an array of characters. So that's the destination, companions 0.name, and the source is going to be this string. So I don't need to have actually made that string in memory as such. I can use I can use a temporary string like this, and that's enough for it to work. So I don't need this line anymore. String copy is replaced to that. So now I can say the first bender has the name Ang, and the element, oops, typing well this morning, is air. So this is the setup for Ang, where Ang is an airbender, so his element is air. That's his name. If you haven't seen the show, this is the main character of the show. I highly recommend it. It's a lot of fun. Fun little TV series that launched a couple of interesting careers in animation later on for a few people as well. I think I spoke about this at some point. I can't remember who I was talking to, whether it was in a lecture or just in a live stream. But anyway, so we also have power and health. These being integers are things that we can just access directly. So companion 0 power. Now Ang is a significantly powerful bender, so Ang's going to be more powerful than most other benders, so I'm going to give him a 10 out of 10. I don't know if this is actually out of 10, but I'm going to give him 10 power. I think I did there. Ang has a certain amount of health. I'm going to give Ang a reasonably low amount of health because he's just a kid. He's a little bit fragile at times. So this is me just making stuff up. But I think he's very, very much more powerful than he is healthy. I'm going to want to do this for everyone in the team because there's no way that I can use this array of companions without them all having some information. There's also no particularly nice way of doing this. Like, I can't really loop through and do this because each of them has their own very specific information. So I'm probably going to have to do this by hand. So what I will do is I'm going to copy paste this for the 4 companions, and then I'm going to put each of their information in here so that they can be used. So these are the 4 of the characters that appear in the show. I don't want to give too much information in case people haven't seen the show and they want to see what it's like, but these are 4 people who appear in the show, and at some point maybe they would be together and in a fight. So there's the second companion. So what I'm doing here is I'm changing this for the second person. This is Katara. And Katara is a waterbender. Um, she's not as powerful as Aang, so I'm going to give her a lower number, but I think she's probably more resilient than him, so she's going to get a 7 here. I'm just making this up. Based on what I know of the story, it'll be fun like this. Sokka is Katara's brother. Um, Sokka is not actually an element bender at all. He has no magical powers, so his element here is none. I'm going to put the 2s in here because he's the third one in this list. Being someone who has no elemental powers, he just fights with his hands and a boomerang. So we're going to put him pretty low on the power scale. But one of my favorite things about Sokka is how much he just generally gets hurt. In the TV series, he's like the one that's always in the way of things when things go wrong, just entirely by accident. So I'm gonna say that Sokka has built up a great resilience for being hurt, even by his friends by accident and things like that. So he's got a lot of health, but he just doesn't do that much damage. Okay, and then there's Toph, who is an earthbender. So, mild spoilers here. Toph isn't introduced at the very beginning of the TV show, but appears later on. Ooh, fan theory that Sokka's a spirit bender. I have not looked up any of those fan theories. Also, what was I gonna say? I haven't actually seen Legend of Korra either, which is the TV series that comes after Avatar. I mean, I'll watch it eventually, but I haven't seen it. Liang is saying Sokka is like Lee in Naruto. If anyone has seen Naruto, Rock Lee is like one of my favorite characters, because like they have Naruto and Avatar actually. I think they both kind of tie into the same tropes where martial artists get magic powers. So the better you get at martial arts, the more control of this magic stuff you can do. And Naruto is based on the idea of Japanese ninjas, but with this really, really overly expanded background of like magic around ninjas, whereas Avatar is based on more of a Chinese style things. Like a lot of the martial arts is very, very kind of kung fu and wushu based in Avatar, whereas I think that the martial arts in Naruto are mostly non-existent. It's much more fun and silly, I think. And so Rock Lee is just pure fighter, so he's just focused all of his potential magic power into the ability to punch and kick, where nearly none of the others do that. Michael, yeah. So we've obviously got some fans here. Michael's talking about Naruto peaks at Rock Lee versus Gaara. That was the tournament, right? I think I remember that. And Leon's asking, is Naruto Boruto's dad? Yes. So this is like classic long-winded anime. There's like 300 episodes of Naruto as a child, and then there's Naruto Shippuden, which is like Naruto as a teenager into an adult, and then later on there's other stuff. So it's, yeah. I was talking to a friend recently. It was really funny because we were talking about like Netflix TV series. So the current like American Netflix TV series, when they come out, you watch them and you're like, that was cool, but it was only 10 episodes. I want to watch more. So you go and watch an anime, and then like 100 episodes later, you're like, oh, can this end? It's like, I've just watched so many filler episodes. They just went to a random village somewhere, helped some people, and nothing happened that moved the story along. And so it's just really funny, this back and forth between the way that different TV series work in terms of volume. Okay, so Toph here. It's hard to say. I mean, Toph being one of my favorites. I kind of want to give her like just stupidly high numbers here. So like, there's an argument here about like who's more powerful between Toph and Katara. like, it's like, oh, I don't know. At which point in each of their development are we looking at here? But I think that I would still. Let's say I'm calling this early. I mean, there's a clue in here that I'm calling this pretty early because like later on these elements aren't exactly the same as what I've put here. So maybe I'm saying this early. And in early days, I think Toph is more powerful than Katara. I don't think Toph is super healthy though. But I don't. I think that she's kind of durable, but I think that's only because no one ever hits her. But I'm just spitballing. I should probably write some code rather than spending 2 hours just talking about the relative strengths of different characters in Avatar: The Last Airbender. Oh, Leon saying manga is superior to anime. I think a lot of people would probably agree with you. The only problem for me personally is manga takes too long and takes too much of my concentration. Whereas for example, while I'm prepping slides or something, I can just have the TV on in the background and go, oh, I'm picking up some of the story, but I don't have to concentrate on it while I'm working on something else. So that's a lot of the times I'll get through a TV series much more easily than I'll get through like a comic that I'm reading or something. Okay, so this is our team, and they've got certain information. I mean, most of this is just stuff I just made up on the fly. I think if we wanted to, we could get into great arguments over a long time on whether these numbers are correct or not, but I'm going to gloss over that because the important thing is not what the numbers are, but what the program's going to be that works around them. Okay, so we've got our team, and then one of the cool things is that the Bender struct doesn't just work for our companions, it can work for our other characters as well. So I'm going to create a character that sits on their own. It's not in the array of companions, but it's actually the enemy that they're going to be fighting. So individual enemy here, and so it is going to have its own variable, which is also a struct bender. So this is the cool thing about making the struct. If we make it generic enough, it can be used for multiple different things, even though they have a different purpose. What did I call him? Oh, I just called it Zuko. That's fine. And so for this variable, I'm still going to need to initialize it with the same kind of thing. So I'm going to copy that. Actually, I don't know if I really needed to copy that because I've got to change all this stuff as well. Prince Zuko is the enemy of these four. And he is a firebender. So the story is that the Fire Nation is against all three of the other nations, and the Fire Nation are, most of the time, pretty bad people that are trying to conquer and rule the other nations. That's the conflict that that kind of kicks off the story in a sense in Avatar: The Last Airbender. Especially at the beginning, before everyone's kind of like developed their characters at all, Prince Zuko is like way more powerful than everyone, and it's really just the best they can do to escape him, rather than even as a set of four being able to genuinely fight him. So he's going to have some massive numbers here. We're going to set this up kind of like a boss fight in terms of like you've got 4 characters and 1 enemy. So 20 and 20 is going to put him in a position to be very hard to beat compared to the rest of them. I wonder if they will do enough damage. I don't know. Let's see. Let's see how the numbers turn out. These numbers are different every time I do this. I think the only ones that stay the same are the first 2 because I put them in the slides, and these ones just move around depending on how I'm feeling when I make the whenever I run this example. Okay, so we've got this individual one here. We need to make sure that this is the correct variable. So, looking at these, I've done companions 0, I've done companions 1, 2, and 3, and then Zuko. So now I have 5 variables, 4 of which are in an array, and 1 of which is on its own. So I've got these 2 separate sets of variables, which I have used to store certain information about characters and what they can potentially do. Oh, Liang's asking about the everything was peaceful until the Fire Nation attacked. That's the opening of Avatar. Um, I don't think there is a Fire Nation in Naruto. There's a yeah, because Naruto they're not called nations. They have ninja villages, and each village has a theme. But I don't even think there's a fire one. There's like leaf and sand and some other stuff. But yeah, I'm not sure. I watched like I think 300 episodes of the original Naruto, but that was like 10 years ago or something like that. So my memory of it is not as strong as my memory of Avatar, which I'm watching again now. Okay, so what we want to do is we want to get to a point where these characters can fight each other. So characters can attack each other, which means we're going to basically apply their amount of power as damage to someone else. As in, we're going to reduce someone's health by the amount of power that someone has. Since this is going to be happening again and again and again, I would like to do this in a function. So one of the good things that we're going to get out of this is if I say someone can attack someone, what I don't want to necessarily have happen is that the um, attacker kind of just changes the health of the defender without checking for things. So it's more than just this one line here. Target health minus equals attacker power. So this is me saying that like someone loses health based on the attack power of someone else. I also want to do stuff like this and check if it's below 0 and then be able to say what's going on. Also in this attack function. So the attack function is really simply at its core, it's just reduce the health of the target based on the attacker, and I'm going to use pointers for these. But it's also going to report to us what's going on, so it's going to printf what's happening. So let's create this function. I wonder if we have output for this function. No, we don't. It's just going to be a void function. Having said that, even as a void function, it's going to have some side effects. So there's going to be change in variables, and there's going to be some print output rather than program output. The fact that it's changing variables means that the variables we're going to want to pass in will be pointers. So I'm going to say that for every attack, there's going to be one attacker, one defender. So for the moment, we're not looking at like multiple people attacking someone at the same time. We're going to do this as a series of one-on-ones. So it's basically going to be like each of these benders is going to fight Zuko one-on-one, and every time that one of them gets knocked out, someone else is going to take over. But for the moment, everything's just going to involve just two benders at a time. So there is a pointer, a struct bender pointer that points at an attacker, and another struct bender pointer that points at the target. I'm going to copy that. Paste that down here, and I'm going to say attack will lower the target's health by the attacker's power. It will also print information about the attack. So, what are we doing here? First of all, we're going to say what's happening. So we're going to do a printf that says somebody, and I'm going to use the %s here because %s allows me to print out a whole string at a time. Somebody attacks somebody. Let's see what information. And I was going to say how much damage they did as well. For an integer amount of damage. Let's put a new line on the end of this because I think this is going to be happening more than once, so we want them to just sort of go down the screen. The variables that we're getting is that first one is the attacker. So this is attacker. Now, for me to access the attacker that's the other end of that pointer, I can put a star here. And then I'd want to get their name So the name would be here, but I can't do star and attacker name. I would have to put this in brackets like this. What I'm getting at is I probably want to use um, the nicer syntax for accessing a field inside a struct that I have a pointer to. So instead of doing all of this, what I'm actually going to do is use the syntax that says, if this is a pointer and I want one of the fields inside the pointer, I just use the arrow. So one of the ways that one of the tutors said, I think earlier this year or last year, they were saying that, like, if this is a pointer, it needs the sharper thing to get to a field. So the pointer needs an arrow to get into the field. Whereas here, where we're accessing the fields of it, this is not a pointer, it's a variable. So there's a difference between this and this. This exists in memory. This is just an address to memory where something else exists. So if I have a pointer, I use the pointy thing. Otherwise, I use the dot. I don't know if that'll help you remember things or not, but hopefully it will. So the attacker's name and then the target's name. And because they're both struct vendor pointers, if I want their names inside, I can use the same thing to access it. And then the amount of damage is going to be the attacker's power. Alright, that line's a bit long. I might make it really nice. Now I can read this vertically, rather than having to go along the line. I can be like attacker name, attacker power. That's what's going in here. Alright, so that's just going to say what the attack is going to be. Then it's going to actually do the attack, which is to say the target's health. And I know that every target has a health integer. Is reduced by, so the minus equals just says take away whatever number I put here. So if it's like 56, this is takes the health, reduces it by 56, and then replaces the health number with the result. So this is the same as, I think I've shown this before, at least with a plus equals. A minus equals is the same thing. So this would be the same as this health equals this health minus 56. So it's a shorthand that just makes things a little bit easier for me. So I'm going to say the health is reduced by the attacker's power. So you can see how me saying, okay, this is reduced by this, my variable names make this really easy for me. So the attacker and target differentiates the 2 pointers really easily. And then because I've said attack power, it's just really easy based on the names that I've put inside my structs and stuff like that. It's really easy for me to use it. Okay, so target health is reduced by attacker power. Okay, so this is what we want to do. We want to be able to say, this person attacks this person, their health is reduced by a certain amount. Then I want to see if the person has been knocked out or not. So we consider when someone loses all their health, they get knocked out and they're no longer going to continue in the fight. So they're lying off to the side somewhere going, ow, I hurt a lot. So if after the attack has happened, if the target health is now less than or equal to 0, target is knocked out. And I think I was just going to print something out. Yeah, oh, I wrote my comments a little differently here, but otherwise, I think it's still quite understandable what I'm doing here. Somebody has been knocked out. And that somebody is going to be the target's name. Okay, so this attack function now allows us to have one person attack one other person. So you may have seen, as you've been watching me write code for examples in lectures and things like that, you may have seen how this is one of the ways, one of the strategies that I approach a complex problem. So the complex problem is, I want all of these benders to be fighting each other, I want them to be attacking each other, and I want to eventually get to the point where either one of the teams, so the team or the individual, is left standing at the end, which means I'm going to need to do multiple attacks, that kind of thing. But what I will always do when I start off is I make something like this, where the functionality here is kind of that. There's so little going on, but what I'll do is I'll go, okay, um, what are the smallest possible building blocks that I need to make this entire program? Let's hit one of them first and get it working, test it out, and see whether it works before I start thinking about the larger scale of what I'm doing. I mean, I'm still thinking about the larger scale because I'm putting some information in here for the idea that, yeah, I'm going to want to know if things have been knocked out. I'm also going to want to be able to print out some information for the user and things like that. But I'm not worried too much about what happens later. I'm just trying to get a small piece of this thing working first. And then I'm going to test this before I go on and start doing other things. So I think this is something that's pretty good to think about in terms of like when you're creating a program where you can't think about all of it at once. And honestly, like pretty much everything we're doing from now on is going to be that. There's never going to be a situation where you can like hold all the pieces of a program in your head and then be able to just sort of implement them all at once. So if I said something like, say for freefall, so I assume a lot of people are working on freefall at the moment. If I said to you, implement stage 4 without implementing any of the previous stages. So I'm saying to you, in your head, you should already know how you'd implemented the previous stages and implement a fourth stage that uses the previous stages without them existing. And I think that would be like nigh on impossible because you'd be like, well, how would I actually do this previous bit? So how would I think about this previous bit and actually get this thing working? So it doesn't make a lot of sense to do that. And so what I like to do is like what I'm doing here, start from the simplest thing, build it, make it work, and then add something more complex, build it, make it work with the simpler thing. And you build upwards rather than thinking about the big picture and then sort of building inwards from there. It's very difficult. Sorry. I was up reading last night, and I think I stayed up too late, so I'm coughing a bit today. Okay, so let's see whether this basic function works. Oh, sorry, we've got some questions here. SK is asking if the live stream is going to be uploaded like a normal YouTube video afterwards. Yes, it is. Yeah, Leon's saying that anytime I stream, they're auto-uploaded. Not necessarily, actually. Usually these are unlisted when I stream because I make them only available to the class. And then I upload them public later so people can watch them if they want. I realized that this term, because this term all of the lectures are online, this is the first time that all the lectures are online. I'd be really interested to see what happens next term or next year or something like that because I think I'm going to get people coming into the class and rolling in it who have seen it all already, and they're going to be like, I can already do this, Mark. I watched your lectures from last year, and it's like, oh, okay then. I'm going to hit a point where I'll run a version of the course. I don't think I can actually do this, but I think it would be pretty funny where I run a version of the course that says, here's the YouTube channel. Email me when you're ready to do the exam. And that's it. So if you can pass the exam, good. So if you've watched the whole YouTube channel in advance, then there you go. Done. I think that would be really funny. I think it actually could be really interesting to do university like that, in like this asynchronous university. So it's not in lockstep and in time or anything like that. You just do it when you can, and all the resources are available online. It would be very interesting to see how well that works. I think that a lot of people would start it and then not have the self-discipline to continue. Because I've done the same thing where I've done online courses that are free and I get like 1/3 of the way in and go, oh, I'm busy now. And I disappear to go do something else. Michael's saying the assignment doc splitting everything into 4 stages actually makes the assignment so much easier. Yeah, I think and I think that's the idea, is that if you can reach a point where you can separate your own work into those stages, it makes things super easy. But, you know, I'm not expecting that from the very first assignment. Even like all the assignments in Comp 1511 are not going to are going to split stuff into stages for you. But it's a skill that you can learn over time, which is like, okay, what do I need first? And then you just do what you need first and test it before you move on to other things. Oh, people are talking about approaching stage 4 in different ways. Joan is asking what people think is the easiest part of stage 4. I don't know, because there's such different things. Stage 4. So the space above the map. I don't want to say too much about it because I'm just going to say you do it like this, right? But I think it's relatively easy, but takes a bit of work. The gravity storm that pulls things in different directions, I think, is harder to think about conceptually and what's going to happen. But there'll be less code to make that one work. Marching blocks is a little bit similar to the extra map, the extra upper map thing, in that it's got some stuff that you have to do with it, but it doesn't bend your brain. I think the gravity storm's the most brain bending one of it, and the others are more about can you just get the code to do different things. So yeah. Anyway, back to our bender fight here. Let's do our testing, and let's just at least test one thing. So let's have Aang attack Zuko and Zuko attack Aang, and then we'll be able to see see whether this thing is actually working or not, so whether the health is changing. So what we might do, well, let's not set up this bit yet. Let's just do a test, and then I'll talk about the next bit after we have a quick break. Okay, so we'll do a simple test, which is call the attack function and have Aang attack Zuko. So Aang is companions 0. And Zuko is Zuko. But I can't necessarily just dump these variables in here like this, because these things are looking for pointers to variables. And if we remember, a pointer to a variable is the address of that variable. The pointer stores the address of that variable. So I can say, just give me the address of these, and that will suffice. That will say to this function, here is a pointer to this. Because remember when I was talking about a pointer, if a pointer was written on a piece of paper, it would be the address written on the piece of paper. So me saying the address of this variable is the same as me saying this is a pointer to this variable. The only difference is I've not created the actual pointer. So the pointer doesn't exist as a variable in memory here, but the address is the value that could be stored in that pointer. So this would be like if I had a function that took in integers. This is the difference between passing in just the number 20 or passing in a variable that happened to store the number 20. So me saying the and of this, the address of this, is just me taking the address value, whereas this thing, the address value of companion 0, is not stored anywhere in memory at the moment. Okay, so this is going to have Aang attacking Zuko, and let's go the other way to test it. So one-on-one between Aang and Zuko, and let's compile this. Definitely kind of overdue for compiling to make sure we don't have any syntax errors, and we'll see how this runs. I'm gonna clear this. This is whatchamacallit. These errors, gedit errors, are usually autocomplete dictionary errors that are not super important. Okay, DCC bender fight. I'm gonna call it bender fight. Oops. Error. Passing struct bender to parameter if incompatible type character pointer. String copy here. Bender fight. Line 51. Line 51. Haha! Here's me wanting to change the name of Zuko, but forgetting that I can't just copy a string into a struct. I need to copy it into the field in the struct that is also a string. So let's get those sorted out. So I can see that I made 2 errors here with that same issue. And let's see if that compiles. Note, I didn't read any of these other errors because not important. The first one's the only one that's important to begin with. Alright, I think I fixed both of them because I saw the second line where I made the same error. Okay, so we've got this now so we can run it. Aang attacks Prince Zuko for 10 damage. That appears to be the first attack finished. And the second one is Prince Zuko attacks Aang for 20 damage. Aang has been knocked out. Okay, that makes sense because I think Prince Zuko does 20 damage and Aang only has 5 health. So that makes perfect sense that he would get knocked out by 1 attack from Prince Zuko. This is assuming that attack actually hits, which is not very often for Aang. But, you know, we're not going into like what is Aang's percentage dodge value versus Zuko's crit rating, and depending on Zuko's crit rating, does he then ignite the area around Aang, causing a damaging field that will potentially apply damage over time to Aang if he lands on the ground near where Zuko previously attacked. This can be countered by Katara's water capabilities that can shut down the damaging area. Anyway, this is how role-playing games are made, by the way. This is how like all of your favorite like Skyrim and all this other stuff is built on these cascading rules of ideas, and you're like, well, I've got a build that is entirely about igniting other people based on crits, and I've got another build which is based on suppressing my enemy using water attacks and stuff. So yeah, this can go off into eternity. But at least now we know that our basic attack function is potentially working. Like, I don't know for certain, I've only done 2 tests, but reasonably working. It's doing 1 attack and another attack that is knocking someone out, which makes me feel like it's probably reducing their health by the right amount. Leon's asking what kind of marks do people typically get for style out of the 20% mark. That's a very difficult question to answer because it's very individual. So I've seen some people get 20 out of 20 pretty easily, just because they're very, very careful with how they write things, and they have been able to grasp early the notion of when and how to use functions. Mostly it's just like code is really clean. I've seen other people get very high performance marks, but pretty low style marks. So I think a low style mark is somewhere around like sort of 6 to 10, where it's like, okay, you've gotten some things right, because it's pretty hard not to get some things right. But there's a lot of things you want to think about for next time, and that's really just kind of feedback for like next assignment, try this, this, and this. What you really want to look at if you don't get a full style mark is any advice your tutor may have given you, or if they haven't given you specific advice, like it's actually in the file that you read when you read the marking. You can go through your code and there'll be comments about what things could be done differently. If you don't get a high style mark, it can be worth actually taking it to your tutor and saying, okay, I want to get a full style mark next time. What are some pieces of advice you can give me about making changes to this? Like, some of that stuff works really well. Michael's asking if it is bad style if there's more comments blue text than regular code. I mean, it depends what code you're writing. If the code kind of explains itself, then you don't need a huge amount of comments. Let me show you. The more comments you make, the more chance you have of potentially confusing someone as to which of these comments need to be read. So look at this attack function here. It's got comments at the beginning explaining what it is, and it has only 1 comment in here. But I still think this is okay, because here's one operation, a printf, and every single thing in this has a whole bunch of English words in it that say exactly what it is. The attacker's name is the first one, attacks the target's name for attacker power damage. This is readable on its own. This is also reasonably readable on its own because of variable names and things. At this point, I'm explaining something. Because I'm explaining what it means for the target's health to be less than or equal to 0. So if my target's health is less than or equal to 0, that means this, right? So I don't need to say something like this. So I don't need to say print out who's attacking who for how much damage, because it kind of nearly says this itself. Prints attacks who's attacking who for how much damage, right? It's kind of all there already, so I don't bother with this comment here, because I don't think that someone necessarily needs that. If you really want to, you can put that stuff in. You're not usually going to lose marks for over commenting, but you might if your tutor, say, is reading through and misses something crucial because there's too many other comments. Unlikely to happen. Your tutors are going to know, kind of generally know more about this than you. Well, that's the notion. If you're learning from someone, they should know more than you. But that they're going to kind of go through and say, all right, I understand what your code does, and that was explained in a way that works. So it depends. I think Dean's saying the same thing. Quality is more important than quantity. Jet's saying that they often comment things, saying the second last element of the array is this, because they forget that, even though tutors won't need that reminder. I think that's okay, because if you need the reminder, you can have a comment in there that's going to remind you of things, because that's going to make your code better. So I wouldn't always comment for other people. You can comment for yourself as well, because in the end, that's going to make your code more functional, and it's going to make your debugging more functional as well, which is important. So I wouldn't ever just not comment something because you think that you want to leave comments out, but you needed it as a reminder. If you need it as a reminder, that's probably the main, like that's a really big driving factor in you saying, yeah, I definitely want that comment in. Okay, so we've got our attack function. The attack function's working. Let's look at using this attack function multiple times in a fight. So we've seen it working in a single time. So we're looking at, I think I spoke about this anyway. So the addresses of the structs are being passed to the attack function. Yeah, this is exactly what I was saying. The function took pointers as input, which means we could give addresses as the variables. And that is like saying that I'm giving a pointer to the function. So this was slightly different to what I was doing. So instead of team count 0 coming in here, I just put the 0 in. But this is exactly what we just did. So we had these two fighting each other once. If we wanted to use pointers, we could set up pointers. So we could say a pointer to a single companion is that, and then the prince could have his own pointer there, and then if I have those pointers, I can just give those pointers as the variables that go in to the attacks. So both of these things are going to do a very similar thing. They're going to have the same people attacking each other, but the second one will maintain these pointers to these people. If we want to, we can, if we want to, maintain pointers to these people, or we can continue just using addresses for these. So, the next thing we want to do is we want to fight until one side loses. So that means we're going to need a function to decide whether someone has run out of health or not. And we've already got a little bit of information in the attack function there, so we were checking if someone had run out of health immediately. But we also have a slightly different situation where we want to know whether the team has run out of health or not, because one of the teams has multiple health pools. So it's more complicated than just saying, has the health hit 0? Because if the health is hit 0 on one person but not the other 3, then someone else should still be able to fight. And that's this next bit here, a loop that keeps the fight going, letting the companions step in as someone gets knocked out. Leon's asking, is it alright if we have star pointer equals star pointer plus 1 in the assignment? I was reading the star guide, we should avoid pointer arithmetic. That's fine, because the star pointer is you saying it's the value at the end of the pointer. So you're not doing arithmetic on pointers itself. You're doing arithmetic on the values that the pointers are aimed at, which is totally fine. Because if you use star pointer, you're looking at a variable, normal variable. You can use it. If you don't put the star on that, so if you do pointer +1, then that's awkward because what you're saying is I'm changing the value of the pointer. So what you're saying, if you add 1 to a pointer, not to a star pointer, but to the pointer, you're changing where it aims in memory. And so you don't really know where that's going to go because that's going to move on to another memory location. And you're like, what is the next memory location that that pointer is going to aim at? So we're avoiding that because it's potentially dangerous and it pushes your pointers into other bits of memory that you don't know about. So when you think about it, there's a difference between going to an address and then fiddling around with the variable that's at that address. That's normal variable stuff. But if I take the address that I have, so I've got address written down on a piece of paper, and I cross it out, so I had like 1,000 Anzac Parade, and I cross that out and I write 1001 Anzac Parade. And then suddenly this pointer is taking me somewhere else. That's the dangerous thing that we don't want people to do. I think Leon, what Shrey was probably saying to you there is that what you were doing is fine because I can see what you're doing there is fine. You're accessing variables and doing maths on variables, totally fine. The trick is if you start doing maths on the pointer values, that's the where the danger comes in. Feng Yuang's asking, does anyone have comp group? I'm not sure exactly what you mean by that question, Feng Yu, so I'm not sure if you want to clarify that or not. Okay, so let's look at these two functions we're going to make. We'll have one function called still alive. Still alive is going to check both sides of this fight. So it's going to check the team as one side of the fight and the individual fighter as the other side of the fight and check whether they're both still alive. So let's write this function. So I'm going to, maybe I'll come back and look at this code a little bit, but I think it's better if you see me write it bit by bit. Okay. Still alive is going to want a pointer to the solo fighter and a pointer to the array of team fighters. We're going to assume for the moment that the team is of team size, so I'm going to put that in here. I wonder if I did that there. I did do the same thing, yep. Alright, so here's my function. I'm going to explain what this function does. Oops, I need it to actually be a comment. Still alive returns 1 if both sides still have some health left. I wonder if I want to make this clear. Not all the benders in team need to have health for their team to be considered alive. I think that should give enough information. I'm going to say it returns 0 if either or both teams have no health remaining. Okay, that should give us enough information for what we're doing here. We're still alive. Oh, right. So Fenya was asking you about messenger groups. I think there is a messenger group. The group is full? Oh, groups have like a 500-person limit or something like that, do they? I can't remember what Facebook messenger group limits are. Right. Oh, so Feng is saying that it's hard to get an answer in the course forum. I think the course forum's got like maybe a 24-hour turnaround time at most, but the difference, I guess, is the course forum you could actually search for other people's answers. You might get the same answers to your questions. That's also an official response. Any answer that you might get in a messenger group is just probably coming from other students, so it may not actually be correct. So just watch out for that. That's the issue, I think. Mm. Uh, I apologize, Fengu. Usually this would be much easier to sort of meet people and stuff if you were here physically for tutorials and things like that. But we unfortunately can't do that at the moment. Um, Michael, you're saying why does the comp course use Messenger and not have a Discord server? The Messenger's not official, so it's not something that we do. We have considered doing stuff like Discord and Slack for the course, but I don't really have the the hours to pay staff to moderate it. So that's why we use a forum instead, because a forum is a pure question answer thing rather than actually having chat. So if we use something like Discord, the chat goes past really quickly, and you'll notice that if you're on any large Discords, the same questions get asked again and again and again. Whereas if we use a forum, we can just aim people back at the answers to the questions rather than having lost the answers to the questions back in chat a long time ago. That's the reason why we've got a structured question and answer style communication rather than just an open communication channel. Um, and Dean's saying that yes, there are tutors to accessible in help sessions. So Fengyu, if you want to, help sessions are a pretty good way to get one-on-one help as well. Okay, so let's make this still alive function. So I'm going to make two integers to say whether the solo person is alive or the team is alive. I'm just going to use these. And I know that I'm going to have to set these up as a value 1 or 0 and then change it depending on what I see. So S alive, let's do one of them at a time. All right, I'm just going to remove that one entirely. So S alive, if the solo bender has health left, then S alive will be a 1. So I could actually initialize this as 0 and say if solo bender health is greater than 0, S alive is equal to 1. So that's an easy one. I'm going to put a comment here saying that's what this section is. Does the solo bender have health? And then this is, does anyone on the team have health? So this time I'm going to have to loop to make this work. So I need the tracker again. So T alive is going to be the variable that says, is someone on the team alive? I think I'll start with the same thing because I'm not sure exactly what I want to do with this. So I'm going to start with saying false until I figure out whether someone is capable of continuing, who has health remaining. And then I'm going to loop. I'm making this up as I go, actually. I didn't actually read the slide well enough to know exactly how I did the code last time, so this might look different for what's on the slides. But what I like to do is, like, if I'm going to solve the problem right in front of you here, then I want to actually talk about how I'm doing it, so I won't necessarily follow the slides exactly. You know this already. You've seen a lot of my examples. They don't follow the slides exactly, but they have me talking through it, which I think is more important. Okay, so if we're going to loop through the entire team, I'm going to say loop through the entire team like so. And if I loop through the entire team, what am I checking for? I'm checking to see if oops, it's not called companions. Looking at the variable that's inside the um, inside the function here. So team I wonder. Oh, I was going, what is that variable? That looks weird to me. I've passed in. This is a potential mistake here. This is I should have left this thing and started compiling it because this would have confused a lot of us. Struct bender pointer. That's the type. Is team. I've actually stored. I've taken as input to this function an array of pointers. An array of pointers to struct benders, which doesn't exist. I have not created an array of pointers. I've only created arrays of benders themselves here. So this wasn't going to work because I don't want an array of pointers. I just want the array of benders. And I was just looking at it then going, how do I access an individual here? That's a bit weird. Okay, so now this is actually just the array of benders, which means I can say team I, and I'm going to get something valid out of that. Okay, so if I have an array of benders, I do team I, and I ask about their health. So here I don't have pointers, I have the actual array, so the actual structs, so I use the dot. Here I have a pointer to a bender, so if I've got the pointer, I use the pointy connector, which is the arrow, which says look at the struct that's at the end of that pointer and its health. So if the health is greater than 0, then t alive is equal to 1. So what I'm saying here is that both of these say no one's alive until we can prove that someone is. So if the solo bender has health greater than 0, then they're alive. Going through the team, if any of them have health greater than 0, then t alive will be set to 1. This is going to go through the whole team. So at the beginning, it's going to set t alive to 1 4 times, but that's fine. So long as any of them have health greater than 0, then at the end of this loop, t alive will be 1. So let's put that there so that we can see for sure. T alive will equal 1 if any bender has health greater than 0. Well, that's nice. Lang's offering to meet up with Pengyu at some point to talk about things. I know it's hard when we're online. It's hard to actually make connections with people, and I apologize for that. I mean, like, I don't really have any business apologizing for that. I didn't cause COVID, all right? I'm just saying, but I still think that the situation sucks, and it's tough to try to learn on your own in a situation where normally you just get to meet people and then you get to help each other and things like that. Okay, so if I have these two numbers now, S alive and T alive, and they're going to be 1s or 0s, I need to figure out what I'm going to return. So let's do something cool. I'm going to show you something. Oh, Jet's saying, can I add to the while condition and not T alive? That's an interesting thing. I could if I want to, yes. I could add this condition here and not T alive, which says that I don't need to check if someone's alive if I've already found someone who's alive, which means this while loop would then end early if I wanted to. So T alive, if it gets set to 1, it's nearly like t alive works as a sentinel variable as well. So this is a loop that ends on number of iterations as well as on this sentinel variable. So as long as I found one person alive, I don't need to keep looping. So that's a cool thing. What you've done there, Jet, is you've actually potentially saved us from wasting extra times through the loop to check if multiple people are alive if we've already found one. And this comment still stands, because this didn't change the sort of consistency of this while loop. So that's an interesting point, and I'm quite happy with that. Yeah. Oh, people talking about linear algebra. I have not done much linear algebra in recent times. Wait, is linear algebra like matrices and stuff like that? I use that heaps for computer graphics and stuff. Anyway, so let me show you this trick that I'm doing here. Return s alive multiplied by t alive. Now, this is a trick that, for example, would allow you to do stuff with order 3 without using if statements. So what I'm actually saying here is these things can be 1 or 0. Still alive is only true if both teams have someone alive. So if both teams have someone alive, this is 1 and 1, which will equal 1. If either team is out of action, then one of these will be 0, and the result of multiplying these two together will be 0. So what I've actually done is this. Multiplying 1s and 0s together is nearly the same. It's not exactly the same, but it's nearly the same as putting an and between them, saying that if either one of these is 0, then the whole thing is 0. So this and this is actually going to give me a really similar result. So I just wanted to show you like a cool trick that I could do that. I could just do this by multiplying. Actually, you know what I'm going to do? I'm going to do it as an and, because this reads better. This definitely reads better because I'm saying this is a logical operator that we can understand. If both of them are alive, we return 1. If only one is alive, we return 0. So I think that was actually not too bad. Like your question there. Who was asking the question? Michael was asking that question because you showed that there was a point of confusion there that someone could get lost, so I changed it. This is like kind of like a live code review. Okay, so now we have a function that says whether the teams are still alive. It's a bit hard for us to test this function. I can at least do a simple test of this function where after this attack I can say do a test print just say what's still alive. Returned if I give it a pointer to Zuko and the Bender team, which is companions. Okay. This will tell me what's still alive returned. I'm assuming that after this, still alive will tell us that that there's still a fight on, because even if Aang gets knocked out by this attack, the others will still be there. I can then test. Okay, I'm going to do something slightly dodgy just for testing. While 10 attack. Who's going to attack? Who does lots of damage? Toph does lots of damage. So what I'm going to say is Toph gets to hit Zuko 10 times. So that'll be plenty. And then I'll printf the output of still alive. So at least this is me testing a few different options for what's happening. This tests whether still alive is okay if one of the companions is down, and I'm testing if still alive is going to return the correct response if Zuko gets taken out. I would probably want to do more tests than this because there's more situations that could happen. I'd want to find out whether this was working if all of the companions were taken out as well. So there's more stuff going on, but let's just run these tests for now and see. Oh, wrong button. So for example, this is how we would write the auto tests. This is also how I would want to do things as I'm creating a program to make sure things are working. So you note that none of this stuff is necessary for the actual specification of the program, which is to run this fight with multiple attacks, but it is going to be necessary for me to understand that my code is working. So let's compile that again. It's compiled. That doesn't really mean it's correct because I've written a lot of code here. So let's see what happens with these attacks and the reports of whether Still Alive is working or not. Oops. This while loop makes no sense. I don't know why. I think I just short-circuited what my brain wanted to do, and I just didn't write correct code. Like, a while loop is pretty basic. I think this is a great thing to see. I think this is a great thing to see someone with like years and years of experience coding just completely brain fart and write something that made no sense. So I said while not even it's like while 10. Just go in my head, run this while loop 10 times. And I just completely didn't write any of the syntax to get 10 attacks from Zuko. Did anyone... Yeah, Jet's like, what makes the 10 in the while loop reduce each time? Is that a feature of while loops? No, it's not, but it should be. If I typed it in, I want it to work that way. Yeah, so I think that was just me just missing the point entirely. So what I really wanted to do was like get this to run 10 times. So when you're in your exam and you're under a lot of pressure and you write a loop like that, don't beat yourself up over it, because it happens. Okay, let's do this again. Hopefully this will run once. Oh, well, not once. It'll run 10 times this time now that I compile this. Oh, and I've left a semicolon off something. Wow. You can tell it's my day today. I'm obviously like... I'm glad this is flexibility week, because my brain is not working at full capacity today. Like, I'm making a lot of hilarious little mistakes here. Okay, let's run this, and we should get... Okay. Aang attacks Prince Zuko for 10. Prince Zuko attacks Aang for 20. Aang has been knocked out, Still Alive returned 1. So, we're seeing here that Still Alive is capable of seeing that with Aang knocked out, but other people still in the fight, it says 1, so the fight is still on. Then, Toph attacks Prince Zuko a few times. Prince Zuko gets knocked out. Probably didn't need to hit him 10 times, but that's a very tough thing to do, to knock someone out and keep beating them up. And at that point, once that's done, Still Alive returns 0, because it's able to see that with one half of the fight out, the fight is over. Riley saying the amount of times you've missed the semicolon in the assignment. Yeah. And look, no judgment ever on people missing semicolons if your lecturer in a demonstration of how to program is also going to miss semicolons. I think, and this is advice not just for programming, but for life in general, is that making mistakes is something that happens. It's something that's a natural part of life. How you bounce back and how you deal with those mistakes is the true measure of what you do. So I'm happy to laugh and say that every mistake I make, we can turn into a learning opportunity for all of you. So I think that's good enough. Okay, so I think that my Still Alive is mostly working. You'll see how I always say this. I think it's mostly working. And then I'll be like, if I really want to know if this is working, I'd run a few more tests. But for the moment, we've got a limited amount of time today, so I don't want to run exhaustive testing for every single function I write. I would say that if you're doing this for an assignment, you're not trying to finish the assignment in 2 hours. You're trying to finish the assignment in 3 weeks. So doing much more exhaustive testing on things is better. Auto tests will do a lot of that for you as well, so it's even easier. We set up the system so the whole system of working on it, the stages, the auto tests and everything, it replicates what we do as professional programmers. It just automates some of it for you so that you can see it happening, and then later on you can be like, well, the auto tests would do this. Like, for each stage, it would test, 18 different things. So maybe I should be doing that much testing on my own programs, which you will end up doing. Anyway, I think my Still Alive function is working. So I've got an attack function, and I've got a Still Alive function that says, are the teams still still able to fight. Knowing this, I probably don't need to attack quite so many times from Toph. Ease down, Toph. Too violent. So violent. Now with these, I can think about the final goal, which was to keep looping and keep attacking until one team is out. And that means I'm going to need to be able to switch companions when a companion gets knocked out. So here's a kind of a main loop that we could create. And so we're going to have this team count, which is the thing that's going to move through the team. So it's like an iterator. It's like an iterator I that loops through the team, but it's only going to move to another team member if a team member gets knocked out. So this is our real thing rather than testing now. So we're going to have a pointer to a companion, which is going to be the current companion. Actually, I don't know if we even need that pointer. I might do it without this, because I might just do an address using the team count. So I probably won't make either of these pointers, but I'm going to use the addresses of things as pointers. Ooh, we've got declare element, because I haven't been using the elements. So I think I made a cool thing where it was like, who uses what element, because I've just put this thing in the struct and I was like, I should actually use it. Actually, you know what? I might not bother with that just yet. We can add that in later, or you can add that in later, because I've got about 20 minutes left. I should work on this main loop first. So the crucial elements of this, I'm going to get rid of my testing now, because I'm going to start to write actual code here. I can't just type normal words today. I don't know what's up. Okay, so the crucial elements of this is we're going to loop through until still alive returns 0. So that's pretty good. I know that I've got my loop there. Still alive as a function is going to act as my sentinel variable for my loop. Each time no, I'm going to need this outside of here. Keep track of the current companion fighting, because only one companion is going to be in the fight at the time. As a companion gets knocked out, someone will step in from their place. Each time, check which companion should be fighting. So if someone gets knocked out, the next companion should fight. Then have attacks from both the current companion and Zuko against each other. So we're going to make it like they both get a chance to attack. So there's a simultaneous attack from both of them. Like, it's not going to be entirely simultaneous because we're going to do one on each line. But we're going to say they both get a chance to attack no matter what. And then after that, we'll check who's still there or not. Okay, so this is the thing that I'm going to do with my main loop. So keep track of the current companion fighting is I'm going to keep an integer that says which is our current companion. So I'm actually going to call that current companion. I called it team count on the slides, but I think current companion makes more sense. Don't think I need that comment anymore because I've got this here. Loop until still alive returns 0. So it's loop until still alive returns 0. So while still alive, still alive needs a pointer to a solo bender first. So if it needs a pointer to a solo bender, it can take the address of the variable Zuko. And it also needs an array of the team, which is called companions. And so while still alive does not return 0, it can keep running. So I actually don't need to put anything else in this function because I'm saying while still alive is equal to 1, we will keep running. But I don't actually need this equals to 1 because this question inside the brackets is looking for a 1 or a 0 answer anyway. It's not even looking for a 1 or a 0, it's looking for any number or a 0. And still alive is already outputting a 1 or a 0, so it's already giving its true-false value. So as long as this thing is true, then one loop of the fight runs. So I might explain this a little bit better. Loop until either the team, hang on, I'm going to make this correct, either the companions or Zuko are out of the fight. So what this is going to do is going to make each round happen so long as there are two people on either side able to continue. So either someone alive in this group and Zuko alive. If they're both alive, then this loop will run. If either of them is completely knocked out, then this will come up as 0 and the while loop won't run. So I say here, each time check which companion should be fighting. So that's going to be inside the loop. Have attacks from both Current and Zuko against each other. That's also going to be inside the loop. So I'm going to put these things in here to remind me of what I'm making. Okay, so if the current companion is 0, or the current companion is whatever integer this is going to be, because it's going to move between them, I need to check whether they should be able to fight or not. So checking something is an if statement. The thing that I am checking is the current companion able to continue fighting? So let's look at companions, which is the array, and look at the current companion there. And what question am I asking here? I'm asking whether this person's okay to continue the fight. The answer would be, are they alive or not? I don't have a function that checks whether an individual is alive. I only have this function that checks the whole group. But to check whether someone is still alive as an individual is much easier, because all I need to do is check their health. So if their health is greater than 0, if their health is greater than 0, then they may continue. This bender can keep fighting. Actually, you know what? I don't need to check that. Because if they can continue fighting, they just continue fighting. But what I do want to check is the opposite. If they're less than or equal to 0, that means they've knocked out. They've been knocked out. Has been knocked out. Move on to the next one. So what I can do there is I can say current companion plus plus. So what I'm saying here is that, for example, it starts at 0. Aang's there. If Aang gets knocked out, then Katara takes over. So the companion 0 gets changed to companion 1 before this next set of attacks happen. The potential danger here is that I move off the end of the list. If I move off the end of the list, it means that I'm accessing out of bounds of the array, and I'll have the attempt to do an attack from a struct that doesn't exist. Cool thing about this, though, is I've got this check. If there are no live companions left, then I will never get to this point where I could potentially move them off the end of the list. So I think that I'm safe here. I would have to do more testing, but I think this is okay. So, if it's not the companion that fought previously, it's the next one, and then we can try to do stuff. Michael's saying, I feel like when he's at negative 70 hit points, he's more paced than knocked out. I'm trying to keep this PG. Avatar was like reasonably PG, where they just get knocked out. And like, Sokka, for example, will just cop hits again and again and again, but he'll just like change shape and go super deformed, but never actually like get hurt that badly. So yeah, that was before when we were hitting Zuko over and over again in the testing. Oh wait, it's not here anymore. I deleted it because we don't need that testing for now. Okay, so if a companion is knocked out, we move on to another companion. I don't know if I need this anymore because this reads reasonably simply. Like that's nearly English the way that it reads. But this I'm happy to explain. Then have attacks from both the current companion and Zuko against each other. Now, I wish I hadn't deleted the code that was in my testing because I had this set up before. But I know it's not that hard because I know it's my attack function. So let's have the current companion attacking first, which is this one. Current companion. And because we want a pointer to the current companion, I'm asking for the address of the current companion as the attacker, and then the address of Zuko as the target. But we said both ways. The attack's going to happen both ways. So I'm going to cut with Control X, paste with Control V here. So what I'm saying is that companions get to attack Zuko, then Zuko gets to attack the companions back. So it's both attacks happening, and both results are going to happen in this round. And then we're going to keep going until no one can fight anymore. So at some point, this will end with either Zuko running out of health or all 4 of the companions running out of health. And at that point, this while loop will end. So I might just put a print here saying the fight has ended. I have a feeling that I want to do more than that, where I would want to say who won the fight as well. But as we're running low on time, I'm not gonna write that code for now because I want to test whether this loop is working. So let's compile this and see what typos I made. Oh, none. That's a little scary. And let's run it. Aang attacks Prince Zuko for 10 damage. Prince Zuko attacks Aang for 20. Aang has been knocked out. Then Katara steps in. So what I'm seeing here is my sequence of moving on to the next bender is working because Aang was knocked out. Katara attacks Prince Zuko for 7. Prince Zuko attacks Katara for 20. Katara also gets knocked out. Sokka attacks Prince Zuko for 3 damage. Oh, Prince Zuko got knocked out. Prince Zuko attacks Sokka for 20. Sokka gets knocked out. The fight ends. Okay, that's cool. So we have a situation now where the fight has gone on. Prince Zuko has knocked out a few people, but at the end, one of the companions, Toph, who never actually got into this fight, is still alive. But Prince Zuko has been knocked out by accumulated amount of damage from everyone else. Okay. Lang Chao saying he doesn't need to say still alive not equals 0 in the while statement. No, I don't. See, the while loop is looking for a 1 or a 0, and still alive itself outputs that 1 or a 0. So I set up the function so it outputs the 1 or a 0. And while is going to say that it will stop on a 0, but it will keep going on any other number. So I didn't need to actually put a relational question here, because this function itself transforms itself into an integer that's going to be 1 or a 0. So it's already answering the question itself. So still alive doesn't have to be not equal to 0 or equal to 1. So I could say not equal to 0 here, or I could say equal to 1 here, but that would result in exactly the same thing as if I put neither of them there. So it's an interesting thing there. Michael saying still alive doesn't check individuals on the team. Set current companion equals current companion mod 4. So still alive doesn't check for individuals, but it checks if anyone is alive or not. So what we do is we're going through in order, and so we're saying the only reason why we would go on to the next companion is the previous companion has no health remaining. So what we're doing is we're kind of consuming them one at a time as we go through. So this, we don't want it to mod 4, because mod 4 would mean we'd be able to go back to Aang. If we can go back to Aang, even though his health is 0, that means we're allowing someone with 0 health to fight, which makes no sense, right? So what we're going to say is if we go through all of them, and we get through them all, then still alive will then return 0. So I'm saying is go through them one at a time, and if they get knocked out, they don't come back to the fight. And Jet saying, what happens if the companion knocks Zuko out? Does he still attack back? may not have completely followed all the steps. Oh, you're saying that answers your question, so I was saying that they both get to attack. Yeah. Um, yeah, Liang's asking while 0 means the loop stops, while 1 or more, or any number other than 0 means the loop keeps going. Yes, that's true. Um, Jet saying that does seem strange where someone's knocked out but they still attack. So that's just the nature of this. If we wanted to, we could say that someone gets to attack first and then the other person gets to attack. So we could have a loop that does two things and stops in between. Or we could even have two loops, one for one of them attacking, one for the other. Actually, no, that wouldn't work. But we could, yeah, we could, if we wanted to, put a pause point in between each of the attacks. But what I'm doing is making it so that, yes, we're seeing that in a different sequence. But these are actually in pairs of attacks that are simultaneous. I'm sort of, I'm fluffing it a little bit here because I don't, especially because I don't have much time left. I'll actually keep going for a little bit because there's more stuff I want to teach you, but I don't want to necessarily super overcomplicate what's going on in this loop, so I let them just be simultaneous. Liang saying, I guess he fell on someone. So it's kind of the idea that Zuko throws a fireball, and then Aang throws an air blast. So they both get to use them, and then the attacks go past each other, and then they still hit each other. Or they both punch at the same time, and they both hit each other in the face, and that's a double KO. So that can happen as well. Um, I forget because I actually have a T-shirt that says double KO. It's a Street Fighter T-shirt, and I remember wearing that specifically when I did this example previously, but I forgot about it today. Um, I'm actually just wearing my normal black hoodie of some kind. I've got lots of different black hoodies, and I just kind of wear the same hoodies all the time. Okay, so this at least is getting us to the point where we can have the fight go through its full sequence. There's other things we could do. So there's the declare element function, which I'm not going to do because I don't think it's super important, but it just makes use of the other part of the struct, where for every fighter they could say this fighter wields this element, so they could declare this thing before each time they fight and stuff. And that was an interesting one because it shows you that you can use the same functions on different benders, whether they're the companions or Zuko. And you can notice this. One of the cool things about attack is attack doesn't really mind particularly whether someone's on one team or another, because they're all bender structs. You can just use them interchangeably in this. And that's one thing I really like about using structs, is that if you have structs that can work for multiple different objects or whatever you're using, you can use a limited set of functions and it will still do everything that you need to do. It's a nice little thing about them. So the one thing I wanted to show you, and this is not accessible. Like we're never going to use this in the exams or anything like that. But people always ask about this, especially because a lot of my early examples are on dice and stuff like that. People were asking me at the beginning of the course, what about random numbers? So I do have some stuff on random numbers. So I'm going to stick around for a little bit longer and make the fight more interesting. Because if we give them random numbers, then the fight outcome is not predetermined. At the moment, the fight outcome is pretty much predetermined because if everyone with fixed numbers, there's no way the fight can ever end any other way than Zuko losing at this point. But if they do a random amount of damage, then things will be different. So, bit of variation. We can use this thing called RAND, which is a random number generator that's part of the C standard library. So RAND is going to give us an integer that's generated from a sequence of numbers that are all reasonably different from each other. It's not actually random because our computers are not very good at doing pure randomness. They can do something that appears random and feels random, but it's not going to be exactly random. So what we're going to do is use that to make sure that every time we run this, we're going to get a different result. So there's two functions here we're going to use. One's called RAND. This is the one that generates the random number. And the other one's called SRAND, that allows us to give a seed to the random number generator. So if I just call rand without calling srand, without seeding the random number, I'll get the same sequence of random numbers every time. I'll show you this working. But if I seed it differently every time, then I will get different sequences every time I run it. So let's grab this. To use rand, I'm going to need the C standard library. It's pretty common to see this one and this one. You won't always see string, but standard input output and standard library will be in nearly every C program you write, because the bits that we use in those are so commonplace that we're nearly always going to have them. I mean, I don't think we've written a single program in the entirety of Comp 1511 that hasn't had standard input output. And now that we know about standard library, this is going to start appearing a lot as well. So standard lib is going to allow us to do random numbers. So if we want to, I can't talk about this. Sorry. This slide assumes you know about command line input, which I have not taught you. So we're not going to do it with command line input. We'll do something else. But let's just look at the randomness to the attack. So we can have a damage number, which is random number mod attacker power. So what I'm saying now is the attacker power is the maximum potential for someone to attack, but they could do any damage between 0 and that power. It's actually 0 and 1 less than that power. So that's what our random here is going to do, and that's going to change the amount of damage done in the attack so that it's not necessarily always going to be the same amount. And then we'll get some interesting stuff happening on our attacks then. So here's our attack. So we're going to make a new integer called damage, and that's going to be equal to a random number generated. So this random number is going to be a random integer, which means it's between negative lots and lots and positive lots and lots. Actually, I don't think it's actually negative. I think it's always positive. Let's find out. That's not the rand I was looking for. OpenSSL rand is definitely not a C rand. So the manual sometimes can't give us everything that we need. So let's go to Google. Rand C. Oh, that auto-completed to C++. Okay, rand, int rand, void returns a pseudo-random number in the range of 0 to rand max. Okay, I know it's a positive number then. Cool, that's good. If it's negative, then I have to fiddle around with things a little bit, but if it's positive, that's okay. So, rand mod attacker power means I'm limiting what the possible massive values of this random number could be to just 0 to attacker power. So they could fluff the attack, or they could get up to 1 less than the power, which is okay. That gives me a random thing that's roughly around like the different power scales for the different people. And so instead of attacker power here, we will use this new integer damage that we've got, and instead of removing health based on the attacker power, we're going to remove the randomly generated damage number here. So different attacks are now going to have different damage values as people attack. Liang Chao, implementing RNGesus. Jet is saying, is the void inside rand optional then? So yeah, if I wanted to, I mean, like, I don't think that would even do anything whether I put the void in there or not. I know that I'm not giving any inputs to this, so I don't need to put anything in here. What I'm doing is I'm just using this as a function that's going to transform itself, in a sense, into an integer value here. So let's just go with this as it is, and we'll see that the fight will come out differently from this fight that we had before. Oops. Yeah, there we go. So this time, Aang only attacks for 3 damage, and Zuko attacks for 6. Katara only attacks for 2, but Zuko smashes her with 15. Um, Sokka, wow, the brother and sister both did very little damage. I mean, that's actually not bad damage for Sokka because I think he has a maximum of 3. And then Sokka gets knocked out by Zuko. Toph fluffs it, does very little damage. Zuko knocks out Toph, but this time it's different from before because the damage numbers have been randomized. So we're not going to get the same result as we got when they were attacking always for their maximum damage. So this is more interesting. We could run this multiple times, hopefully, and get different results each time. So let me run it again and let's see what happens. Oh, this is weird. How come we're getting the same thing again? What we're getting here is the fact that the random number generator is not random. It's a little bit random. Oh, hello. Someone is reporting to us that it is random. Yes? Do you want to say hello? Somebody was bugging me to come sit with me so she can say hello to you. Oh, look at that little squishy face. So Chicken's here to say hi. So, the interesting thing we're getting is that the random number generator is giving us exactly the same sequence of numbers, no matter what. So what we want to do is, if we want this to be different, we're going to need the random number generator to be seeded with a different number, which is going to cause it to start its sequence at a different place, in a sense. And then it will give us different pseudo-random numbers. I want to say pseudo-random because it's not genuinely random. It's just some complicated maths that make a sequence of numbers that don't necessarily follow a pattern that we as humans can discern. But it is actually just mathematically generated. So, what we're going to need to do with this random thing is to seed it. So, let's do it here before the main loop of the fight starts. So I'm going to call srand, and srand is going to need a number of some kind. So if I just put a number in here, that's going to give us a different random number sequence, but it's going to end up being the same sequence over and over again. So let's just try with me putting the number 16 in here, and I compile this and then run it. I now have a different sequence of numbers. So you notice, you can see the flow of the fight is completely different. So we've got Zuko and Aang doing a certain amount of damage to each other, Zuko and Katara. So Aang and Katara get knocked out pretty quickly. And then Zuko magically does here very little damage to Sokka, and Sokka gets multiple chances to damage Zuko and fails miserably multiple times. Classic Sokka. This is where he manages to hit him with a boomerang, which only annoys him. This is where he falls over. This is where he drops something and then he gets knocked out. It's classic. This is like running just like the show. And then Toph comes in, and Toph like smashes Zuko. Does heaps of damage. Takes a bit of damage. Both of them get knocked out. The fight ends with everyone on the ground, double KO, everything's over. So here we're getting a different sequence, but if I was to run this again, I'm getting the same sequence. Because yes, I have seeded my random number with a different number, but it's the same number every time. So what I want to do is to have this number here change into something else. So what I might want to do here is ask the user to type in a number, and they type in a different number, and every number they type in is going to be a different possible fight sequence. So let's do printf. So let's seed the random generator with a number, and then we'll scanf that number. Oh, you need to scanf into something. The random seed. I'm going to start off at 0 just in case I don't get anything out of it. and I'm going to give scanf, now that we know what this is, I'm giving scanf the address of that variable so it has direct access to that memory so it can write into it. Random seed, and then I'm going to put random seed in here. Okay, so let's run this and see what we can do with our random seed. I'm going to compile that. You know what actually could be cool is the fight, this whole section here that runs the entire fight. I could loop this infinitely so that you could just type in different random seeds and you get different fight outcomes rather than having to rerun the program each time. For the moment though, let's do this. Type in a random seed. Okay, I'm going to type in 5 and I get this fight. This fight's different. So Zuko and Aang attack each other. Zuko and Katara attack each other. Zuko and Sokka. And I think Zuko won this one. Oh, Toph left it. She missed. Yeah, so I think Zuko won this fight because he's still there and everyone else has been knocked out. If I run this again, type in a random number like so, I get a different fight. So this is how our random number generators work. They're not completely random. They are a fixed sequence of numbers that, as a human looking at it, we're not really going to see that this is a mathematical sequence. We're not going to be able to discern that. It's random enough for our purposes. But what we usually need to do is to give it a number to start it, and then it goes off and generates the random numbers. So here we got a different kind of fight where, well, I think the companions lost again against Zuko because I didn't think Zuko got knocked out there. If I run this again, oh look, if I type in 5, I'm going to get this one again. So because I did 5 there and 5 there, I get the same thing. So this is to show that the random number generator isn't purely random. It's always going to take in some kind of seed, and then the sequence is actually predetermined. So depending on your philosophy of how you see the world, if you think the world is completely predetermined and deterministic and there's nothing random at all, then this feeds into that philosophy. Or you think that there is true randomness in the world and chaos theory and all this kind of stuff, this is just the fact that the computer can't do it. So, bit of random philosophy there. One interesting thing that people often do with this random number generator stuff is instead of seeding it manually like we're doing now, I'm seeding it manually to show you how it works. What people sometimes do is they just take the clock. So they just look at what's happening in the clock of the computer, because anytime you're working with a computer, there's usually libraries where you can ask them what the time is. I think it's called CTime in C. I can't remember. I haven't used it recently. And what you can do is you can just take the current time in the computer, punch that in as the seed, and then run your random number generator. And because the current time is at least reasonably random, it's going to be a different number every time you run the program, you'll get a different sequence of random numbers each time. That's a common way of doing it that we would often do with a random number generator. Michael's saying if I don't set random seed to an integer and the user doesn't input anything, will random seed run like rand or just not work? Rand will always work in terms of this function will always give us an integer, regardless of whether we've seeded it differently or not. In this case here, if we don't get a proper seed for scanf, this is just going to be 0 here. So it's just going to get seeded with 0, which means it's going to end up with the same sequence every time if we don't have something. If we took this thing out completely, then we'd get the situation where this still works, because we did before, right? When I put rand in without seeding it, I was getting the same sequence every time. So that's okay in a sense, but if every time you're going to restart the program, you get the same sequence coming out, your randomness is going to start to look less random the more times you do it. Liang was asking, is it possible to seed it with the PC's internal time? Yes, as you can tell, because that was the thing I was going to say. It's like definitely something that happens. Let me just. I don't know if I can just search it there. C time. C library function time will give us returns time since the epoch January 1st, 1970. So it gives you the number of seconds that have happened between 1970 and now. It's in time.h. If seconds is not null, return value is also stored in the variable seconds. Following is a declaration for the time function. It gives us back a type called time t, though. I don't know if time t is a valid integer, but we can try it anyway. So let's do time.h. We'll include time.h there. This is me going off track, by the way. I don't expect anyone to actually have to use time.h in 1511. I'm just doing it for fun. So instead of this, I'm going to seed srand with, what was that function? Time. And can I can I just call that without anything else? Yeah, I can call time null and I'll get something, but whether time t converts to an integer automatically or not, we'll find out. Time null gives me the current time, and let's see if that can go into srand. I'm gonna have to compile this to find that out. Oh, okay. So apparently time t, the variable type, which we've not used at all and we're not going to be using in this course, is something that can work as an integer. So it's just a number value, which means now every time we run this, we should get a different fight. So we've got this fight, and let's run this again. Oh, we've got a much longer fight that's different. So it's always Sucker. Sucker sometimes survives long enough to get a few hits in on Zuko. We could run this again, and we get a different one. So long as I don't try to run this twice in a second, I'm not going to get exactly the same random seed, so I'm going to get different random sequences. And so we could watch this over and over again and see who wins. Probably should have put a line at the end saying who won, but that's not too hard. I'm sure you can do that. You could run that with if statements and stuff like that and just say, okay, who still has health left? Who's the current companion who has health left? And see which team is winning at this point. Yes. Okay, so that was a fun little thing with using random numbers and this. So I point out that this is like flexibility week, so I'm not introducing any new content that's accessible. So all this stuff about random number generation was just a little side thing that we're looking at. It's not necessary. It won't be used in any assignments or the exam or anything like that. It's just a fun thing to be able to do. It's nice to be able to generate random numbers, and we've seen a way to guarantee here that those random numbers are going to be different every time we run our program. So long as we run our program more than a second apart, because I think this thing's in whole seconds. Yeah. So that's everything that I wanted to do today. I mean, there's little bits that I would want to continue with this. So one would be maybe I want to use these elements for something. So maybe I would want to say that certain elements have power over other elements and modify things, or maybe I just want to print out what the elements are, so I don't have these strings in here that I'm never using, because I've got these strings for their elements and I'm not using them anywhere in this fight. Another thing that I'd want to do is here where the fight ends, I probably want to put some information in about who actually won this fight. So I want to do some tests on who's alive. It's not going to be trivial because who's alive and the companions isn't always counted based on the current companion, because the current companion could be knocked out, but there could be another one available. So we'd have to do another thing that is similar to still alive to be able to say who won the fight. But I'm going to leave that to you because we've gone for 2 hours and 20 minutes now, so it's long enough. Hopefully what this gives you is an interesting look at our first use of structs. So how do we use a struct? How do we use pointers to structs? How do we access elements inside a struct sometimes using the arrow if we're accessing via a pointer, but if we're not accessing via a pointer, we're accessing the actual struct variable itself, we use the dot to access the field inside the structs. So all these little things like that will help you slowly learning about this. Next week we are going to come back in. We're actually going to sort of go back over structs again, because this isn't compulsory viewing or anything like that. But I wanted to just do this big example where you get to see lots of different stuff happening with structs and strings, pointers with structs. And we did some cool stuff with the random number generator. This is me just going, all right, what's in these libraries? Can we pull stuff in from these libraries and stuff? You know, especially the time one, because we were like, oh, we can do time, but I haven't done time in ages. The one I was thinking of, C time, is a C++ library, and that's something I do because I do C++ as well. So I didn't even have the right library, but all I need to do was look it up and go, what does this thing do? Can I use it? Tried using it, saw if it worked. I mean, there's potentially going to be an issue here because this was a time t variable type, which I don't really know anything about. But I'm assuming that the time t variable type allows you to do other things by splitting it up into minutes, hours, days, and stuff like that. But I don't know. Haven't looked at it recently, especially not in C. But it worked well enough that it was a random enough time that we could use this to seed our random number generator, which means that every time we run a program, it was a bit different, which is nice. So I'll leave that with you. I'll put this code up in the lecture section as well, so people can go back over it. I have a feeling that this lecture, I mean, like, there weren't that many of us live, but I think this lecture is going to be live stream is going to be used much more. I think it's something for people to view later. When we get into using structs and stuff next week. So I think hopefully a lot of people just take some time off this week and just relax, try to finish the assignment and stuff like that, rather than getting too caught up with extra content. So I will see everyone on Thursday. Thursday, my talk is non-technical. It's all about how you want to work, how you want to kind of live your life. It's not that deep, but it's a little bit. So it's about professionalism and about like what it means to care about what you're doing, which I think sometimes is advice that resonates even further than all the technical stuff we're doing, because the technical stuff comes and goes. At some point, people are going to stop using C as a programming language, so all of the knowledge that you're going to have about this is going to be useless. And we have to go into every programming language we learn knowing that the pure syntax that we're doing is eventually just going to be superseded. But the skills that we gain in shaping programs, the skills that we gain that can go beyond languages, they're still important. So the professionalism talk is not even about that. It's about working. So working with yourself and other people and things like that. So come along Thursday if you're interested. If not, it will obviously be recorded so you can see it later. Alrighty. Liang has a question before we head off. Go nuts. Happy for you to ask a question. I think Liang is typing in a very long question right now. Lab 6, Term 3, 2019, second last challenge question. Okay, so what you're saying here is that you want to really test my memory to see if I can remember what that even is. I'm not sure. Having said that, that set of exercises that does encryption and decryption stuff, I'm pretty sure we're still going to be using something very similar. So we may even still have that question in it next week in the tutorials and labs. So I think that might be a question that you want to take later, because working with encryption and strings at the same time is a lot of fun. Um, I'm not sure. I would have to look up that question to figure out exactly what it is, because I haven't prepped that tune yet for next week. I would suggest just wait till next week, because next week's tutorial and labs might even have that question still. There's a distinct chance that we will still have that question in the week 7 lab, but I'm not sure. Um, I was gonna look up my plans, but I'm actually streaming everything right now. I don't wanna tell you. I don't want to put stuff in the lesson plans on the stream unless I'm sure that it's actually going to be in the plan. What is it, chicken? Sorry, she's sitting here with me and meowing at me. Yeah, wait and see. If it isn't, if it doesn't end up in the tutorial, then ping the forums, or you can send an email to CS1511 and we'll talk about that. But I think for the moment we'll just wait and see, because there's a chance that you'll get your answers in the tutorial and lab. Okay, I'm gonna head off. Chicken here is gonna head off with me also, and I will see you all Thursday. I'm actually doing another thing with CSE Soc tomorrow afternoon, but up to you whether you want to come along to that, because that one's kind of aimed at thesis students, so it's going to be a little bit different. It's going to be very different from like first year content. All right, see you all later, and goodbye. She's waving. I don't think she wants to do this. Goodbye, everybody. All right, see you all.